We're looking here at a geologic map of Yellowstone National Park, and the different colors represent different geologic units, different rock types, different ages of rocks. You can see that all of the pink units in here, these represent the very youngest lava flows, mostly, that erupted at the Yellowstone volcano. Most of these are between about 160 and 70,000 years old, and we see that they're covering up this area of the park. It turns out this is the Yellowstone caldera. It starts around here and it moves out into the area over here, and it's about 50 miles long. And it formed when this green material erupted. This is called the Lava Creek Tuff, and the age of this unit, it's found here in the light green and the dark green, also to the south. The age is 640,000 years. This was an enormous eruption, and it spread ash over much of the United States, and a similar eruption to that today would certainly be a big deal. But since this time, there have been about 80 different eruptions at Yellowstone. Some of them are very big. This one is the most recent. It's 70,000 years old, and it's called the Pitchstone Plateau lava flow. In fact, the size of it is about the size of Washington, D.C., and it's about 100 yards thick in most places. So this is what we're looking at. We can see volcanic rocks everywhere, evidence that this is a really unusual place. It's a massive volcano. Some of the eruptions from Yellowstone are truly enormous eruptions, some of the largest ones that are known of on Earth. And that includes this green unit here, the Lava Creek Tuff, as well as the purple unit, which is the Huckleberry Ridge Tuff, which is erupted 2.1 million years ago. So these are some of the largest eruptions that we know of on Earth, and because they erupted so much material, on the order of 1,000 cubic kilometers or 250 cubic miles, then they get termed as super eruptions, really big eruptions. And the way that it works, this is kind of new terminology, and super eruptions, if you're a volcano that has exploded and created one of these deposits, then you get called a supervolcano. And that's where the word supervolcano comes from. So you have this magma that's beneath the surface, and when it erupts and comes out, there's no longer support for the ground surface up here. And as a result, the ground surface just caves in, it founders and it falls in. You're left with what's called a caldera. It's a subsidence or a feature, or a cave-in feature that's caused when it loses its support of the underground magma. As a result, when it first formed, you had a hole that was on the order of 50 miles long and maybe even 1,000 or 2,000 or 3,000 feet deep in places. We have this deep magma chamber, and there's a lot of heat. The magma is generally at temperatures like 800 degrees centigrade, or something like 1,300 degrees Fahrenheit. There's a lot of heat. That heat heats up the rock, and that rock then, there's conductive cooling, there's water down there. That water gets heated up, and so much of the water that's near the surface at Yellowstone is actually at boiling temperature. And as you go down, it gets hotter and hotter. So that's creates a pressurized system of a boiling aquifer, of boiling groundwater, and that becomes unstable. It can cause earthquakes, and of course it causes the thermal features that we see everywhere at Yellowstone that make Yellowstone so famous. The geysers, the fumaroles or steam vents, the hot springs that are so beautiful and contain so many different kinds of life and thermophile bacteria. So that's what makes Yellowstone special, and it's pretty much all due to this underground magma system. So we have these massive eruptions that are really quite rare, and then we have these lava flows that happen more frequently, but still not. The last one was 70,000 years ago. But this would be a really big event if it happened again within the park. It might cause forest fires, it might dam up rivers, and it would cause a lot of commotion and anxiety within Yellowstone, but it would have very little long range effect. It wouldn't affect people in states that are hundreds of miles away, certainly. We have other big events that occur at Yellowstone. For example, earthquakes. In 1959, there was a magnitude 7.5 that occurred out near Hebgen Lake, caused a lot of damage in the park, and also caused a lot of changes to the thermal areas within Yellowstone. The Teton Fault is on the border of the Teton Mountains south of the park, and it potentially could have a very big earthquake associated with it. Beyond that, we have the hydrothermal explosions or steam explosions when the groundwater system becomes too pressurized and erupts during some sort of perhaps an earthquake or due to a change in lake level. And what happens is you get the groundwater system can form really large holes in the ground, sometimes hundreds of feet across. This is a turbid lake right here, Indian Pond and Mary Bay. All of these were created in the last 15,000 years by explosions of the hydrothermal system. In this case, no magma is erupted, and they're fairly localized events in terms of their damage, but they're still definitely relevant for what's going on at Yellowstone and need to be watched. Almost every year, somewhere in Yellowstone, there is a small hydrothermal explosion. Sometimes they might only be a couple feet across, but we find evidence for them. Sometimes we see a little bit of smoke coming out or fumes coming out in a place we didn't expect it. Sometimes somebody hears it. And in lucky cases, we actually get to witness one of these explosions, and that's happened every few years as well. We have no way of predicting these explosions, especially the smaller ones, but we hope that as time goes by, we'll get more and more knowledge about how they work, and maybe get the chance that someday we'll be able to be able to have some predictive capabilities for these explosions. I'm Jake Lowenstern. I work for the U.S. Geological Survey, and I'm the scientist in charge of the Yellowstone Volcano Observatory. Today we're going to talk about some of the eruptions that occur at Yellowstone, have occurred in the past, how big they get, how we know when they might be coming, what we need to worry about, what we don't need to worry about. The last one of these mammoth eruptions, so-called super eruption, was 640,000 years ago, and that created this green deposit, the Lava Creek Tuff. There were three of these really large eruptions. There's the Lava Creek Tuff, then there's the Huckleberry Ridge Tuff that's 2.1 million years ago, and then you can just make out down here, this is the Mesa Falls Tuff, and it erupted 1.3 million years ago. It was a bit smaller than the other two eruptions. Since the eruption of the Lava Creek Tuff 640,000 years ago, we've had a lot of eruptions within the caldera, probably 80 different eruptions both within the caldera and outside the caldera. Many of them are these really large lava flows. The most recent lava flow was down here on the Pitchstone Plateau 70,000 years ago, and it's a really enormous eruptive unit. These are big eruptions, but they're just within Yellowstone, and they don't appear to be highly explosive. Besides that, we have a number of smaller eruptions that are similar in composition. These are rhyolite lava flows. They're really sticky and gooey and don't move very far from their source. And these are in pink. We also have basalt lavas that are more similar to what gets erupted in Hawaii. It's more rapid moving material. And they're found out here outside the caldera and then out in the area to the east as well. One of the reasons that we know that Yellowstone still has an active magma system, other than the fact that there's so much heat coming out, is the fact that we never see these basalt lavas actually making it out of the caldera. And that's because it's denser than the rhyolite, and it's also relatively, it can't penetrate through this very viscous, sticky, and less dense material. And as a result, it just ponds beneath the rhyolite magma chamber, and it loses its heat to the rhyolite. When you're outside the caldera, the rocks are cooler, and there isn't any rhyolite, and the basalt can just create cracks and come up and make it to the surface. But when you see people claiming it's overdue, usually the numbers they come up with, they say that the last eruption was 640,000 years ago, but that it erupts every 600,000 years, and so therefore it's 40,000 years overdue. But in fact, if you average the eruption intervals, there's 2.1 million to 1.3 million, and then there was another eruption 640,000 years ago, and you average those numbers, you come up with something that's over 700,000 years. And so in reality, even if you tried to make this argument, it wouldn't be overdue for another 70,000 years or so. But the other thing that is important to realize is that when anybody does statistics based on 2 eruptive intervals, they're just kind of playing games, because we don't know. There's no clock down there. The magma is going to erupt when it wants to erupt. There's been a lot of things that have happened over the last 600,000 years that might indicate there's less likely of an eruption. For example, about 500 or 600 cubic kilometers, or a couple hundred cubic miles, of magma was erupted just in the last 150,000 years. So you might think that that would slow the clock down in terms of the next eruption. The last piece of evidence we have in terms of the next eruption at Yellowstone is that when scientists or seismologists do tomography, when they, like a CAT scan on a human being, you do a tomographic image using seismic waves. And when they try to image the magma chamber, generally they find that the magma that's down there is not wholly molten. There may be molten bodies down there that are on the order of 100 or 200 cubic kilometers, but they don't see this massive magma chamber that's all molten material. So we don't expect that there's enough liquid magma down there to produce one of these immense eruptions as has happened in the geologic past at Yellowstone. Having said that, we don't know everything. It's possible it will erupt. It's possible it'll have small lava flows. It's possible, but not very likely, that it'll have another massive eruption. Ultimately, this is stuff that's happening 4 or 5 miles beneath us. But everything we know seems to indicate that nothing right now is truly unusual. The kinds of activity we see at Yellowstone is the kind that's been going on for the last 100 years. And from our geologic evidence, has gone on for thousands of years before then. Well, occasionally we get swarms of earthquakes, and some of these swarms can be quite intense. We had one here in 2009 and the end of 2008 that was almost 1,000 earthquakes, and there were many of them that were above magnitude 3. Some of them were felt in the northern part of the lake. But that's pretty much all that happened. We had no evidence that there were any explosions that were occurring. The caldera had been moving up for a period of years, for about 4 years, and the caldera had moved up about this distance over a very broad area. But we didn't see any change that was occurring when the swarm was happening. And so we didn't really see any of the other indicators that would make us really think that something bigger was about to happen in terms of a volcanic activity.
Northwest, I'd be considering moving. Seriously. The gist of it is this. The federal government estimates 13,000 Americans will die in a major earthquake and tsunami in the Pacific Northwest. It's not a question of whether, but when. This earthquake is coming, and it's overdue.
This morning, the most popular article on the New Yorker's website is rattling many Americans. The really big one examines a titanic earthquake and tsunami, but not where you might imagine.
A fault line called the Cascadia Subduction Zone runs for 700 miles off the Pacific Northwest coast. Experts think it will trigger the worst national disaster in North American history, and it is overdue.
It's predicted to be worse than Hurricane Katrina, worse than the San Francisco earthquake of 1906. Scientists and FEMA, the Federal Emergency Management Agency, are warning of a pending doom for the Pacific Northwest. An earthquake along a little-known fault line that would kill thousands and affect millions.
Consider that the magnitude 9.0 earthquake in Japan, just a few years ago, remember that? Killed more than 15,000 people in the north of Japan and injured thousands of others. Seismologists say that the quake that will strike on our Pacific Northwest coastline should be even stronger, at up to a 9.2. They call such a quake a margin rupture quake, and it's every bit as bad as it sounds. Here's the reason for it. Our entire continent sits on the North American tectonic shelf, right? Plate, I should say. off the coast of the Pacific Northwest from the top of Washington State all the way down to northern California. This is it. And another plate called the Juan de Fuca is trying to slide up under North America, but it's stuck. We have an illustration over here in the big wall. Let me show you what this is. This is our continent here. This is the Cascada Mountains. This is the Cascadia, what do they call it? The Cascadia what? Bridge. The Cascadia Bridge. I was actually asking him, but thank you. The North American plate here and the Juan de Fuca plate here. This one's sliding up under, and eventually this is going to go down, send a huge wall of water up. That wall will go all the way over to Japan, and the other will come onto our shore within 15 minutes. And when it slips, it will unleash not only a colossal earthquake, but also that tsunami, 700 miles long, and in some places up to a 100-foot high wall of water and whatever it's pushing, like houses and dump trucks and schools. Thousands and thousands will not escape. The New Yorker quotes a FEMA official who says, and I quote, "Our operating assumption is that everything west of Interstate 5 will be toast." Everything west of Interstate 5 is gone. That's Seattle, Tacoma, Portland and Olympia, Salem and Eugene, wiped out. Altogether about 7 million people. That's not including tourists. So think of summertime. The New Yorker reports that FEMA calculations indicate the disaster will damage or destroy about 1 million buildings, including 3,000 schools and 1/3 of all fire stations. And perhaps the worst part of all of this, these sorts of earthquakes happen at regular intervals in exactly this part of the world, have forever. On average, according to seismologists, about every 240 years. So when was the last one of these? These massive 9.2 or so earthquakes? Well, the last one was more than 300 years ago, the year 1700. It struck in the Pacific Northwest and sent a 600-foot wave of water all the way to Japan. So right now, on average, the Pacific Northwest is decades overdue for the really, really big one.
CBS News science and futures contributor Michio Kakuka is a physics professor at the City University of New York. Good morning.
Morning.
So it's overdue. When will it might come?
Well, this is the mother of all earthquake faults. It can pack a wallop 30 times that of the San Andreas fault. So forget all the Hollywood hype about the San Andreas fault. We're talking about an earthquake, a 9.0, similar to what devastated northern Japan, which killed over 15,000 people and caused $250 billion in property damage.
Cascadia subduction zone stretches about 700 miles from Cape Mendocino, California, to Vancouver, Canada. Big cities expected to be affected include Seattle and Portland. Some scientists believe the earthquake, when it goes off, will reach between 8.7 and 9.2 on the Richter scale and cause a tsunami.
The last big one was 315 years ago. We think the cycle time is roughly 240 years. Do the math. We are overdue in this calculation with another big one.
We've known about the Cascadia subduction zone for quite a while. It's a serious risk. A big earthquake in the Pacific Northwest could be the worst disaster the country has faced historically.
All around the world, large changes to both Earth's climate and the stability of its crust and tectonic plates has been observed for years with building alarm. After a series of devastating earthquakes hit Mexico, killing hundreds of people, and volcanoes all across the plate boundaries rumbled back to life, many experts and scientists are becoming increasingly worried that the Ring of Fire has awakened. The first and most important place to start is by understanding what the Ring of Fire is and how all of this is connected to our current time. The Ring of Fire represents a series of large tectonic plate boundaries in the Pacific Basin, covering more than 25,000 miles, which includes 75% of all the active volcanoes on Earth. Roughly 90% of all earthquake activity on the planet occurs along this dynamic boundary, showing the extreme instability and dangers associated for communities living near them. The Ring of Fire is created from numerous plate boundaries interacting against one another, either from being subducted or uplifted. This collision is the trigger for what causes both earthquakes and volcanoes. Millions of people live in close proximity to these faults and often forget how active they can become. Our short lifetimes as humans pales in comparison to that of the geologic record of time, which shows devastating events that occurred 12,000 years ago, leading to the rapid end of the Ice Age and the disappearance of ancient civilizations long ago we now only consider just a myth. During that time period, evidence suggests that the tectonic plates of the planet became disrupted by a possible pole shift of the magnetic field of the Earth, which led to enormous tsunamis and volcanic eruptions that changed the entire climate of the planet for thousands of years. This time period, known as the Younger Dryas, featured rapid warming within the planet and disruptions to the oceans and plates from some unknown gravitational force not yet acknowledged by mainstream scientists that seems to be periodically affecting the Earth every few thousand years. After years of record global temperatures across the planet, with melting glaciers and ice caps, this rapid warming cycle of the Earth and the building pressure within is once again leading to great instability of the crustal plates, climates, and oceans, and is raising alarm bells with many scientists. Over the last several months, thousands of medium-sized earthquakes, known as swarms, ranging up to 8.1 on the Richter scale, have been affecting the entire Ring of Fire plate boundary with increasing intensity. Most of this activity has been largely ignored by the media out of fears of panic to society. These earthquake swarms along the fault lines have been accompanied by increased volcanism, with more than a dozen active volcanoes along the Ring of Fire boundary, and others threatening large eruptions, such as the 10,000-foot Mount Agung in Indonesia, where thousands of people have been evacuated, with the highest threat level issued. So the big question is, what is this all leading to? Most should all remember the destructive events of 2011, when large earthquakes set off a series of deadly tsunamis which wiped out entire coastal areas across the Indian and Western Pacific basins. Before that event occurred, very similar signals began appearing, with several months of intense earthquake swarms and volcanoes across the entire plate boundary. This cycle seems to repeat itself over and over, and there are strong indications, looking at all the evidence around the planet, that the events that are occurring now may be leading to something much larger. This information is not meant as fear-mongering, but to inform society of the truth of what is occurring around our world, and to warn of much more serious events that may come. We must as a global collective stand together during these challenging times, and stay informed of what is happening around the planet, and not allow fear and greed to rule our world. Just as we are changing, the Earth is in a constant state of change, and we must either adapt and get smarter about our actions, or disappear just like the past civilizations before us.
You know, all the scientific thoughts that we've been given, things that we were told were, this is how things are. And then we constantly find it's just not the case. The Yellowstone supervolcano may have formed in a completely different way to what we have thought. So the whole thought of this being a mantle plume that rolls from down around Baja California and goes straight up through California, Nevada, Utah, up into Yellowstone Park in Wyoming, it might be something totally different that's going on here, and it might not actually be a plume at all. So as it turns out, the Yellowstone supervolcano in Wyoming may have formed in a entirely different way than previously thought. And this is according to a brand new study published in the journal Nature Geoscience. Researchers from Virginia Tech found evidence to suggest that a vast slab of oceanic crust, or oceanic plate, wedged itself under the western portion of the North American continent around 30 million years ago, breaking into pieces in the Earth's mantle. This process eventually led to volcanic activity on the surface and formation of a long-dormant supervolcano. A large volcano that has an eruption magnitude of 8 or more, the highest value on the Volcanic Explosive Index. The newly proposed idea directly contradicts the long-held view that Yellowstone was produced by a plume of magma rising up from the Earth's core through rifts or weak spots, weak regions in the crust. This is known as the plume model. A team led by Ying Zhou, a theoretical seismologist at Virginia Tech's Department of Geosciences, took X-ray-like images of the Earth's deep interior with U.S. Array, an underground observatory funded by the National Scientific Foundation. And the scientists used a technique known as diffraction tomography, which enabled them to essentially see subterranean structures using waves created by tectonic movements. When these occur, seismometers at the U.S. Array picked up the vibrations, and this data was then processed to create an image of what lies beneath the ground. This is the first time the new imaging theory has been applied to this type of seismic data, which allowed us to see anomalous structures in the Earth's mantle that would otherwise not been resolvable using traditional methods. The Yellowstone supervolcano is a caldera. It's a large hollow that's formed when a volcano collapses after a large eruption. In the case of Yellowstone, the caldera, which measures approximately 30 by 45 miles, that's huge, was formed approximately 630,000 years ago following a cataclysmic eruption at Lava Creek. The Yellowstone caldera forms part of a wider region of volcanic activity known as the Yellowstone Hotspot Tract, which comprises a line of calderas extending across Oregon, Idaho, and Wyoming. So it's been moving and moving eastward, as we have seen. Most volcanoes are found on the boundaries of tectonic plates, but this volcanic hotspot is located right in the middle of the North American plate. Previously, the plume model has been used to explain the location of the Yellowstone Hotspot Tract, but the researchers found no evidence for this in the latest study. If the North American plate was moving slowly over a fixed plume at Yellowstone, it will displace older volcanoes towards the Oregon-Idaho border and form a line of volcanoes, but such a deep plume has not been found. And that's exactly what you have in Hawaii. It's definitely a plume, and you could see the whole line as it trails. And you could even see the angle, as I've spoken about before, where all of a sudden it veers to the east. And that, many think, is indicative of crustal displacement. And a pole shift where the crust actually slips, in that case, about probably almost 90 degrees. Instead, the anomalous geological structure they found, which was located about 250 to 400 miles beneath the supervolcano, followed the path of the track. This indicated that when the oceanic plate, known as the Farallon Plate, broke into pieces, a section of it tore off and sank deep down into the earth. This sinking section gradually pushed hot materials upwards to form the supervolcano. The next step for the researchers is to increase the resolution of X-ray-like images and to recreate the fragmentation of the gigantic oceanic plate and test different scenarios of how magma systems fed the Yellowstone hotspot. So, yeah, when you think of what Velikovsky was talking about, worlds in collision, Velikovsky definitely was a proponent of crustal displacement, and as well as Hapgood. And so these gigantic plate movements are not necessarily always by what we classify as standard plate tectonics, but really crustal displacements where you have like whole sections of continents that might be 2,000-3,000 feet above sea level, and then boom, drop straight down and become, you know, the bed of an ocean. That's the type of thing that that's talking about. But this is interesting because this just points to the fact that once again, what we're taught to be the truth, you know, is sometimes proven and often proven to be, oops, we were wrong. We told you it was this way, but you know what? It wasn't this way after all. So it's probably this now, and maybe that's wrong, but we shall see. Hopefully we'll get some solid answers. All it does is basically, you know, it's just another reason to keep your eyes open and to not necessarily completely believe in anything that you're reading out there. There are some crazy things going on, and one of them is this Arctic lake mysteriously disappearing. And this is up in Russia, and it's baffling geologists and scientists. They went on an expedition, and they thought they were going to find a 1.5 kilometer long lake, and they found just this. Dry, just a dry reservoir, empty, totally empty. Its bottom scarred by cracks and fissures, and the lake is gone. So, and actually this was at least 3 kilometers long at its longest point. This is not, you know, something small. And this is all gone, disappeared. And they are baffled. They don't know what caused it. And over here we have going on monsoon rains, apocalyptic lightning, and pitch black clouds as thunderstorms batter Britain. Hailstones the size of golf balls. Huge thunderstorm tore across Britain. The good news is that it's going to put the current heat wave to an end, thankfully. And so you can see the size of some of the hail. And hail has been something that we have seen everywhere. And there's several videos here you guys could click on and check them out if you want. Of course, there will be links here, as always. And also, what we've been talking about, Australian drought. Farmers plea for bullets to put down starving livestock. It's getting that bad now with these extremes that we're seeing, with the extreme weather, the extreme heat, record heat, right? We have record heat everywhere now. We've had record cold. We've had record snowfall. And we're having record winds. We're having record flooding. So all this is adding up to, basically it's adding up to the food supply is in danger. And it's starting to get to be obviously serious to many folks now. And this is down in New Zealand and Australia. They're having they're having issues. This is New South Wales. Farmers claiming a shortage of bullets to euthanize emaciated stock. It's horrible. An Australian farmer is to cull his entire 1,200 strong flock and give up farming as the drought takes over, killing up to 10 sheep on his farm every day. And it's going to shoot 1,200 sheep. That's, you know, it's just it's a financial catastrophe. It's just a catastrophe, period. And you know, this is not just happening down there. This is happening all over, as we're going to see. And as this says, New South Wales farmers desperately seeking feed from all over Australia as the drought deepens. The bulk handling system has very little grain left in it. And a good family member here as well in Missouri was talking to me, and she was saying that there's like some serious price gouging going on, and she's a farmer, and what they want now is like incredible compared to just a few months ago for feed. I mean, it's going through the roof, and this is part of what we have been expecting, honestly, and it's going to keep increasing. And it's not just in one location. Bolivia, heavy snowfall in Bolivia kills 18,000 livestock. Drought in one place, snowfall in another place, two totally different continents. The same result is going to be livestock slaughtered, and then also a lack of food, and it's building. It is really building. And so this heavy snowfall reached 12 inches, and they lost roughly 20% of 70,000 head of cattle, 80% alpaca, 20% llamas in this territory. And just an extreme event. In this one area over here, Santiago de Machaca, the snowfall reached 2 feet, and the animals died from either the cold or from suffocation as a result of being trapped under the snow. So extreme conditions. And then this adds, we're looking at the wheat prices. And you know, yesterday when I went to the store, it was like all the less expensive bread was like, it just was empty. The only thing that was there was basically all your most expensive organic stuff. So I'm not sure, you know, what exactly is starting to hit, but yeah, there are shortages hitting. Wheat futures are up almost 29% in 2018 in a market buoyed by a diminished crop outlook in the US, European Union, and Russia. Buyers have stepped up their purchases further in recent days with expectations that prices can climb even higher. Serious concerns about the crops from the Atlantic to the Urals, and their analysts are so far is focused on Europe and the Black Sea. This is enough to change the game. French consultancy ODA has lowered its estimate for 2018's European soft wheat harvest by 205 million bushels, for a total production of 4.589 billion bushels. Reductions stem primarily from France, Germany, Sweden, and Denmark. And France and Germany, we've seen tremendous hail, tremendous flooding. And Sweden, we've seen the fires and the intense heat. And Denmark, haven't really seen too much from Denmark, honestly. So I'm assuming they probably have also gotten the floods that Germany and France has gotten as well. And so, you know, this is all just starting. Ireland seeing its poorest grain harvest since 1993. German wheat production down 15.1% from last year. The list goes on and on and on. And I just want to catch one more thing there. This one for you guys. This is a massive monster, 32 meter wide, 50 meter deep crater, swallowed up parts of a field in Russia. And so this huge crater just opened up in the middle of a field, and thank God it wasn't like in a housing development. I can imagine a crater like that size down here in one of the developments in Florida opening up. You would have so many houses just gone. Sinkholes are a very scary thing, and this thing is 150 feet deep and like 90 plus feet across. This is massive and scary. So we're seeing this. We've seen this in other areas as well. We have definitely seen this in other areas around the world as well. So record high temps. We have Shreveport hitting 108, an all-time July record. We have Death Valley breaking record as the